the Turing Award, it look like the Nobel Award for the computer science. Yes. With the deep learning, when I checked in last year, with there a lot of citation. Same with the machine learning. Deep learning can divide to 4 types. The first is deep supervised learning. The second is deep unsupervised learning. The mix between deep supervised learning and deep unsupervised learning, we have the deep semi-supervised learning, and the last is the deep reinforcement learning. Here is some example of deep supervised learning with the INN, recurrent neural network. Along short-term memory with the 4 gates. The INN, we have only 1 gate, but in the LSTM, we have the 4 gates. By the 4 gates, we can remember or forget the last result or last picture in for the next month. And by resonant LSTM, it means that we have the 2 LSTM with the forward and backward. Combination of forward and backward LSTM, we have the bidirectional LSTM. And next year, convolutional neural network is proposed by Prisma in 1980 and improved by Likun, Otto, Benzo, and Harter in 1998. In the CNN, there are 3 main layers here: convolution layer, map-pooling layer, and fully connected layer. Here is some famous CNN model from the ILSVRC contest. For example, RedNet in 2015, GoogleNet in 2014, VGG in 2014, yeah, AlecNet. Yes. And here is the evolution of convolutional neural network from the Likun by the symbol model like the RedNet, AlecNet, VCG, GoogleNet, as CNN, Inception, yes. ResNet, DenseNet, yes. And another is a transformer model. It's proposed by Vaswani around 2017. Another is a deep unsupervised learning with the very resonant autoencoder. Using graph convolution neural network or generative adversarial network, and yes. You can read more detail in the paper. It's the footnote I note here. And next, I will give some experiment. What is big data? What is AI and machine learning to pure data analytics? And we will divide it into the first in the upstream oil and gas industry, and the second in downstream oil and gas industry. In the upstream, we have the big data in exploration, big data in drilling, big data in reservoir engineering, and big data in production engineering. Yeah. And in the big data in the downstream oil and gas industry, we had big data in refining, big data in oil and gas transportation, and big data in health and safety security. Next example, how to predict the CO2 emission. I had the data set with 13 picture. So in this slide, so in this slide, model year, make model behind class engine side, cylinder transmission, fuel time, fuel consumption CT, consumption HWI, combo, and fuel consumption MBG, and the last year CO2 emission. And you can see the data set here in more detail. Yes. Okay, and I will keep. I will remove the first, the second, third, fourth, and the seventh picture. Keep only the eighth picture for the prediction, the CO2 emission. And how to predict CO2 emission? Now take a look. First, I will upload the data to the Google Cloud. Okay. And like I will explore the data set by checking what is this data set. Yeah, we see that there are a lot the data set here with the file record. With the 13 picture. Yeah. And like I will take a look how many column and row in this data set. There are more 1067 row and 13 column. Take a look. We had 13 column here. And one, okay, 1068. Yes. 68, yes. With the headline, the title. And next step, we want to know more detail about this data set. However, this is only when we see in the result here, and we see that it online apply for the number data, numbered data. It means that take a look. We have the engine, cylinder, fuel, 4 type fuel, and combustion. It means that we have 1, 2, 3, 4, 5, 6, 7. 7 is the number of the data. So the result only is only for the number of data. We had the count, the mean, the mark, the mean, and when you see this right here, you can understand more about your data set. How about the histogram with this command? We can show the histogram here. Yeah, you can take a look. That's right. Yes. Histogram, and when you see histogram, you can know more detail about your data set. And the next, how to scatter plot matrix. Yeah, we will draw the scatter matrix like that. And next step, how to predict the CO2 emission. Take a look. Just last year we had a picture, and we see that we had a 7 picture for the chaining, and the 1 for prediction is the CO2 emission. Yes, as it means that we had here is for X chaining, and here the Y. And when you see in the full time, here is not it's not number, so that we had to change this data to the number by the one hot vector. It means that we will check that how many times